Hi everyone, in today's lesson we're going to talk about how to solve log equations. There are three different situations that will arise when you have a log equation. So the first situation is one that will have one log. So the general rule of thumb is that you're going to use the loop-de-loop and then solve using the calculator, common bases, raising both sides to the reciprocal, or just algebra to solve. So let's look at the first situation. So again, look at all of these. They all have one log, or ln. ln is the same type of thing. So they all, again, have one log. So the way that we solve them is we use the loop-de-loop. So circle the base, go up to the power, and come back down. So 3 to the 4th power equals x. Okay? So what I mean by using the calculator is just put in the calculator 3 to the 4th power. If you already know it, you don't have to, but the answer is just 81. Okay? So that's one that is simple and it works nicely. Okay, let's look at one that would require common bases. But before we can do that, we actually need to, there's a typo. So this actually needs to be log base 2 of 1/4 equals x. Okay, so we're going to do the same thing. Use the loop-de-loop to rewrite it as an exponential. So 2 to the x power equals 1/4. And the only way to solve for a variable in the exponent is to use common bases. So I'm going to rewrite 4 with a base of 2. So 2 to the x is equal to 1 over 2 squared. 4 is the same thing as 2 squared. Then I'm going to bring this up. So 2 to the x equals 2 to the negative 2. And then cross the bases off, and the answer is x to the equals negative 2. Okay, now let's look at a situation where I need reciprocals to solve. So again, we're going to circle the base, go up to the power, and come back down. So 5x minus 1 to the 1/3 power equals 4. Now the only way to isolate this x is if you raise both sides to the reciprocal. So I'm going to raise this to the 3 over 1, raise this to the 3, or 3 over 1, same thing. These will cancel. I'll be left with 5x minus 1 equals 64. 64 is the result of 4 to the 3rd. And then we just solve. So we'll add 1 to both sides. So 5x equals 65. Divide both sides by 5. And x is equal to 13. Okay, now it says to check for undefined values. Now, what do I mean by that? This number in here cannot be 0 or negative. So this is a 1/4, that's okay. This is a number, that's 4. But the number here, or here, or here cannot be negative. I'm going to prove that again in class tomorrow, but for now, let's just solve and make sure nothing in here is 0 or negative. Alright, so let's take care of a problem that requires algebra. So rewrite this using exponents. So this to the 2nd power equals this. So x plus 4 squared equals 17x minus 4. Okay, now the rest of the problem is just algebra to solve. We're going to have to double distribute this side. So this is x plus 4 times x plus 4, which is x squared plus 8x plus 16. And we are left with this, 17x minus 4. Now you should be saying, I have an x squared equation. The only way to solve those is to move everything over to one side, set it equal to 0, factor, and t-chart and solve. Okay, try that and then hit resume when you're done for the answer. Okay, here we go. So minus 17x plus 4. So you should have gotten x squared minus 9x plus 20 equals 0. X minus 5, x minus 4. X is equal to a positive 5, and x is equal to a positive 4. So now we needed to check these values that we got. If x equals 5, when I plug x into here, will this thing be positive? And absolutely will be, because 17 times 5 is far greater when I subtract 4. It's going to be positive. How about 4? 17 times 4 minus 4, yes, positive. So we're checking to see that in here is positive. So this works, we're good to go. Okay, using algebra for the second problem, I have an ln. Remember that ln is the same thing as saying log base e of 4x minus 3 is equal to 2. So now I could do the loop-de-loop. E to the second power equals this. So e squared equals 4x minus 3. So now would be a good time to get your calculator out if you don't already have it. So pause the video if you need to grab it. Alright, so type in e to the second power and hit enter. You should get approximately 7.389 ... equals 4x minus 3. Now keep this value in your calculator so you can use all of the digits. And now let's just solve for x. So keeping all of those digits in your calculator, hit plus 3. And you'll get 10.389 ... equals 4x. Again, keeping all the digits, divide by 4. And we get 2.597 ... equals x. Question says round to the nearest tenth, so approximately 2.6. Okay, perfect. Now let's move on to different types of situations that you may have. Okay, we could have a situation where I have logs on one side. So you see I have 2 logs over here and then no logs over here. So what we want to do is condense and then use the loop-de-loop to solve using any of the methods above or on the other page. Again, checking for undefined values. So we're going to condense. So which property uses addition to expand? You should be saying multiplication. So let's condense this to log of x plus 3 of 2x plus 3 times x plus 5 equals 2. So I took this addition problem and made it into a multiplication into one single log. Now we're going to rewrite this using the loop-de-loop. So this all is that. So this becomes x plus 3 squared equals 2x plus 3 times x plus 5. Now again, basic algebra to solve. So this becomes x plus 3 times x plus 3 equals 2x plus 3 times x plus 5. Alright? So I'm going to set you up for the second problem over here, and then I want you to solve both of these with the algebra. Okay? So the second problem here, we have a subtraction. So subtraction means division. So we have log base 3 of x squared minus 4 over x plus 2 equals 2. Use the loop-de-loop method. So 3 squared equals this. And 3 squared is 9. And the best way to solve this is to put that over 1 and to cross multiply. So take a minute, cross multiply this, get it equal to 0, factor, solve, and check. Same thing here, distribute, 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 get it over to 0, solve, factor, and check. Alright, and then hit resume for the answers. Okay, here you go. My answers were x equals -1 and x equals -6, and x equals 11 and x equals -2. So take a minute, pause the video, and copy down any of this algebra in here or algebra in here, but really that's algebra that we can work out tomorrow. The concept that I want you to get is really using loop-de-loop. So first condense, use the loop, rewrite it as an algebra equation. Then check your answers. Why did I reject the -6? Well, here's the reason why. Because when I plugged in -6 here for this x, -6 plus 5 is a -1. This thing cannot be negative, so it doesn't work. When I plugged in x equals -1, it worked. 2 times -1 plus 3, it's positive. You plug in -1 here, it's positive as well. Now, why did I reject the -2? Again, because -2 plus 2 was 0. And when you plug in -2 squared minus 4, you get 0 as well. So this does not work. Okay, let's try the last situation is when I have logs on both sides. So what you want to do first is condense if necessary, and then cross off both logs. Okay? So the first one, I don't actually have to condense anything. If I have the same log with the same base, you can assume that this has to be equal to this, kind of like a common base. So this can cancel with this, and I'm left with 7x plus 3 equals 5x plus 9. And then quickly solve for x. So x is equal to 3. And let's check it out to make sure it works. So x equaling 3, 7 times 3 plus 3, that'll be positive 2. So we're good to go. Okay, now let's look at the second example. Condense if necessary and then cross off. So are these two, I can condense them for sure. It's log base 7 of x minus 2 times x plus 3, because I'm multiplying, right? Addition becomes to multiplication, equals log base 7 of 14. So now that I have one log on one side here and one log on the other side, I can cross them both off just like a common base, and I'm left with x minus 2 times x plus 3 equals 14. And now, again, just some algebra to solve. So solve it and check your answers and hit resume when you're finished. Alright, so I got x equals -5 and x equals 4. So if you need to, pause the video and copy all the algebra down. But I rejected -5, and here's why. Because when I plug in -5 minus 2, I get a -7. Same thing here. -5 plus 3, that's another negative. It's -2. So this one does not work, but this one does. Because when I plug in 4, I get a +2. And when I plug in 4 here, I get a +7. So those are your two answers, and that's about it. We're all finished. All right, see you in class tomorrow.